Live. Okay, so let me flip it back so we can do the objective. So the objective today is to finding angles from triangles and the unit circle. Okay? So it's really the inverse. It's the inverse function. It's the inverse function because everything's got an opposite, right? When we did sine, cosine, and tangent of an angle, we found a side. When we did sine, cosine, tangent of an angle, we found a side, right? What's the opposite of that? Okay, so now we have a side or a ratio, and now we want to find the angle. Does that make sense? So to do that, it's an inverse. So we're going to use a trig. I like to say call it trig inverse, and that's basically the symbol for inverse. Everything has an inverse, an opposite. So when we do the inverse, we're doing the inverse of trig. And the inverse of trig would be to take a ratio and get an angle, right? And that's going to get us an angle, right? Do we agree? That's going to give us an angle. So that button, inverse, gets an angle. I know I've said that several times. You just want to pound that in your head. Okay? So let's flip the page. Now, so from the unit circle, so we kind of played around with it a little bit. We noticed that on the unit circle that there are two possible answers, right? So when we did, for instance, sine of theta equals 1/2, right? When we did that, we found that the 1/2 value is here at 30 degrees and here at 150 degrees, right? It can't be both. It can be one or the other. So what we said is that the trick is to always take the angle that's closest to 0, okay? So we're going to get theta equals 30 degrees and theta equals 150 degrees, okay? But we can't have both. For it to be a function, one x value to one y value, right? You can't have one x value to two y values. It doesn't work. So the 150 doesn't work. So we said use the one that's closest. So here's what we do. The domain. So for sine inverse of x, the domain is going to be from negative 90 degrees less than or equal to x less than or equal to 90, okay? That's the domain. That's where we find the angles. And your calculator is going to agree with me. So anytime you do any sine inverse, your answers are going to be between negative 90 and 90. And here's the thing that I want you to see. It actually kind of makes sense. You see, with sine, you get repeat values in quadrants 1 and quadrants 2. Think about this. With sine, you get repeat values between quadrants 1 and quadrants 2, which means you can't use both of them. You can't use both of them because if you use both of them, you get two different answers for the same. So quadrant 2 can't be used. But you don't get repeat values between quadrants 1 and quadrants 4. If you look at your y values, they're different than the y values up here. Okay? So you have to use quadrant 4 and quadrant 1. So let's write that down. That's the same as quadrant 1 and quadrant 4. Okay? This is where you find your angles. And I'm going to highlight that because normally I won't say negative 90. I'll say which quadrant. I'll say quadrants 1 or quadrant 4. I'll talk about quadrants versus angles. Does that make sense? I'll say it's found in either quadrants 1 or quadrants 4, right? And you guys do know the quadrants, didn't you? I'm sure Mrs. Downs taught you the quadrants go like this. Quadrant 1, you do know this, please. If you don't know this, then just lie to me and say, of course, Mr. Davies, we know that's quadrants 1. This is quadrants 2, quadrant 2, quadrant 3, right? And quadrant 4, okay? Give me a raise of hands if you've seen quadrants before. Okay, hallelujah. This is a good day. Okay? Now, cosine. So cosine inverse of x is between 0 and 180. That's where you find the angles. That's where you find the angles for cosine. And that is quadrants 1 and quadrants 2. So cosine is quadrants 1 and quadrants 2, okay? So I'm going to highlight that, and I'll show you on the unit circle why that makes sense. It really does make sense when you take a look at the unit circle, okay? So we take a look at the unit circle, okay? Just going to put this down when you get this written down. If I look at the unit circle, we can't have repeat values, right? We can't. So if I look at the unit circle and I look at my x values, 1, see my x values, then I get to quadrant 2 and they're just the negative, so they're not the same values, are they? But if I look at quadrants 1 and quadrants 4, the x values are actually the same. And you can't have two answers, right? It wouldn't be a function, right? So in quadrants 1 and quadrants 2 for cosine gives you, okay? And then finally tangent, okay? Tangent inverse of x.
Quadrants 1 and 3, right?
Actually, it's going to be 1 and 4 because 3 is too far to go. 1 and 3 actually repeat. They do repeat. Okay? So we're going to go from, again, negative 90 to positive 90. Oh, I made a mistake. I really did. Now I have to fix this. And now you guys are going to have to tell me why I have to fix this. Okay? Write that down. Don't write everything down. Watch. I got to fix it. I have to take out the equal sign. Oh, man. Why do I have to take out the equal sign?
No clue.
You have no clue. Somebody tell me why the equal sign has to be there. Has to be there.
Those already equal to
Let's take a look at the unit circle.
I don't know
What's
what
the
I'm saying.
tangent of 90? What's the tangent value of 90?
0.
Nothing.
Nothing. So it can never equal 90, can it? Okay, it can't equal 90, right? Because that's going to make Cookie Monster sad. Because 1 divided by 0 is, can you divide by 0?
No.
Oh, so it can never equal 90, okay? And then the same thing down at negative 90, right? There's negative 90 degrees. So on my domain, I've got to go x is greater than negative 90 and less than 90. So that puts me in quadrants 1 and 4, okay? How's that? Does that make a little bit of sense?
There's nothing in quadrant 3.
So the problem with quadrant 3, yeah, there's nothing in quadrant 3. Quadrant 3 is not used at all. In fact, if you look at the tangent values, so the tangent values, see that my tangent values are in green? They repeat from 1 and 3. So 3 obviously can't work, right? Because you can't have repeat values, right? And then the thing about tangent is this. If I wanted to go all the way to quadrant 2 would work, but quadrant 4 is right there if we go whoop down, right? Does that make sense? So the trick is always, which one's closer to 0? Which one's closer to 0? Well, if I just boop down, that's closer than going all the way to quadrant 2. It's that easy. Which angle's closer to 0? I'll say it again. Which angle's closer to 0? And that's the way to tackle this, okay? So now, if we know that, let's take a look, okay? Find the following. So, example 3. Now, 5 pi 6. I'm not looking for an angle. I'm looking for a y value, right? We'll do the angles down here. So sine of 5 pi 6, okay, I can do that. Now that's an angle, so write unit circle. 5 pi 6 is right here, right? Right there, there's my angle. That's an angle in radians. I'm looking for the sine value, so I'm looking for the y value, which is 1/2. Would you agree with that?
Oh, yeah.
So it's just 1/2. That's my answer. Cosine 7 pi 4, okay? Cosine 7 pi 4.
315.
It's right there, same thing, 315. And if I want the cosine value, I'm looking for the x value. Square root of 2 of 2, right? Square root of 2 of 2. Okay. Tangent 5 pi thirds. Again, 5 pi thirds is an angle. Okay, 5 pi thirds is right there. I'm looking at the tangent value, which is my negative square root of 3. Okay. Thumbs up? So these pi thingies, they're actually angles. They are actually angles, okay? But they're angles in terms of radians. Now, 4, we're going to find an angle. Because it says sine of theta equals 1/2, right? So we have to find the angle. So we're going to find a y value. We're looking for a y value. And it's got to be close to 0. 30 is totally right. So found it. Y value of 1/2. It's right there. It's 30, okay? Now, Saul, you're totally right, except for I'm going to change your answer because the directions say in
Radian.
radians. So it's my angle.
5 divided by 6.
Yeah, it's not 30 degrees. Well, it is, but if I want the angle and rate, it's pi over 6, okay? So it's theta equals pi over 6. Nice job, Saul. Okay. Cosine, negative square root of 2, so we're looking for an x value. All right, let's see if I can find it. X value, negative square root of 3 over 2. Quadrants 1 or 2. It's got to be right, negative square root of 3 over 2, right there, right? You guys found it? Right there? So I've got it at 150 degrees, but we need it in radians, so the angle is 5 pi 6. See how this works? So theta is 5 pi 6, okay? Tangent of negative square root of 3. Okay, now this is a hard one, but I know we can do it, okay? So where is it? Well, it is over here at 2 pi thirds, right? It's here at 5 pi thirds, but it's neither one of those answers, actually. It's going to be a negative pi thirds, because we're going to go boop. Hold on, wait a minute. I like things, Lavi. So which is faster? Which is faster? Going all the way to here, all the way to here, right? Or going, you ready? All the way around to here, right? I'll do it again. Which is faster? Going here, or going all the way around to here, or just going, thanks, Lavi, going boop, right to there, right? So if I boop, I got to go down. I'm going negative. I'm rotating backwards, so that's a negative pi thirds. You see that? It's a negative pi thirds. Okay, great question. Yep, I will explain. Okay, so if we want to rotate down toward it, right? So think about how far it went. The equivalent would be to go up that much. Pi, see, pi thirds. But instead of going up that equivalent, we're going to go backwards. Pi thirds. Now, what I've done before, which you can do if you want to, is we can put in the negative angles. I don't know if you want to put these in. That's a negative pi 6. Isn't that a negative pi 6? If we want to add that to a unit circle, see? That's negative pi 6. This would be a negative pi fourths, right? If this helps you, right? We'll write them in, the negative angles. This would be a negative pi thirds, and this angle would be a negative pi halves, okay? Same angle, however, a different rotation. Same angle, different rotation, okay? Is that helpful having those on there?
Yeah.
Yeah. You don't need to, but you can if you want to, okay?
Can you do it with us?
No, I'll do that later, okay? All right, so then finally, D, let's do D. That should be, I got D, E, F. Wow, look at that. D, E, F, my bad. So, sine inverse. So this is saying find the angle, right? This is actually saying find the angle. That says right there, we want the angle. Find theta in radians, right? That's actually saying find the angle. So I want a y value. Y value of negative 1/2. Y value of negative 1/2. It's right there, right? It's right there. So let's bip down to it. What's the answer? Negative pi over 6, right? So theta's got to be bip, negative pi over 6. Awesome. Cosine 0. Cosine 0 is an x value. X value. Who said that? Pi over 2. It's right there. It's right there. Pi over 2. Nice job, Jeremy. Yep. So theta is pi over 2. Okay. Thank you, Jeremy. Tangent. Negative 1. Tangent inverse of negative 1. Negative pi over 4. Negative pi over 4. Everybody see it? Here's your negative 1 value for tangent. The angle is, if we bip down to it, right, here's the negative 1 for the tangent value.
Oh, okay, yeah.
And if we bip down to it, because that's the shortest distance, we get negative pi over 4.
I understand, David.
I knew, because you're a smart guy, I knew you would. So the unit circle is really not that bad. It explains trigonometry really well. That's why we learn it, because the understanding of trigonometry, if you get the unit circle, you really understand trig. Yes, Ashley.